we are going to be talking about the effects that these changes have on some linear function. So those graphs that you guys were just plotting, just some linear function where we have a slope and a point. If you make any of these changes, what does that look like on our graph? All right, so first we're going to talk about vertical compression. Okay, so most of us figured this out or asked a question about it prior to turning that assignment in today. But compression, just in the general sense of the word, means to like put pressure on something, right? To push something down. So if I had a line here and I push down on it, it should be getting flatter, right? Okay, so when you have vertical compression, this means your graph is getting flatter. As far as numerically, this means that your slope is decreasing. Okay, so if your slope was 3 and it went down to 1, like the one in the example, the slope decreased, right? Or if it was 1 and it goes down to a half, or if it was a half and it goes down to 1/5, right? Any of these would be compression. So this means your slope's absolute value decreases. Okay, and when we say absolute value, what did that mean again? What did the absolute values do in our equations that we had it in our formulas for? Right. So the negative in front of a slope would not determine compression or a stretch. Okay? We're only looking at the number itself. We're not concerned with the positive or negative value of it. All right. Then on the other hand, we have vertical stretches to our graphs, which in this case, if you're stretching something, it should be getting steeper. Okay? So here my graph is steeper. And in this case, your slope's absolute value is increasing. Alright, then we have our reflection across the x-axis. So this is where your negative comes into play. So my negative is not going to affect compression or stretching, but a negative is what's going to reflect your graph. So whenever you reflect across the x-axis, so remember our x-axis runs this direction. Whenever you reflect across this axis, all of your y coordinates change to their opposite sign. Okay, so if I was at 2, 1, I would now be at 2, -1, right? So it's just going to flip it across that axis. All right? This also means that if I do this, it flips the direction of my line, right? If I had a bunch of points that were like this, and now all these points are down here, and all these ones are up here, it completely flips the direction of my line, right? So your slope will become opposite as well in this scenario. All right, then the last thing we'll have is our translations. And translations just mean you are picking your entire graph up and moving it somewhere. Maybe you're moving it up, down, left, right. So your graph moves up, down, left, or right. in this case, your slope is not going to change. And because your slope's not changing, that means this part must be making a change to the y-intercept, right? So here your y-intercept increases. If your graph goes up. And it's going to decrease if your graph goes down. For our linear functions, we're not going to see a lot of left and right shifts. If you did, it would be inside of a parenthesis with x. Okay. So if it wanted to shift your graph so many units left or right, you would have x minus 2, and then your y-intercept would still be out there on the end. All right. Okay. So now they want us to graph what these kind of changes would look like. All right. So the first thing we're going to graph is the parent function. Parent linear function. So that means that it's as basic as it gets, right? It hasn't been shifted up or down, so it starts at 0, 0. And it hasn't been stretched or compressed, so it just has a slope of 1. So you're just going up 1 and over 1 for each point here. So this is y equals x, which is the parent function. All right, so first thing we talked about was compression, right? We said compression means that our slope is getting smaller. So what would be an example of a slope smaller than the one in our parent function? 1/2, that would be perfect. All right, so we're going to show compression by making the slope 1/2. Okay. This is showing our compression, still starting at 0, 0. We're not going to move it anywhere, but instead of going up 1 over 1, I'm going to go up 1 and over 2. And we said that this means the line gets flatter. Well, it's definitely flatter than the parent function, right? Going over more than it's going up. All right, the second thing we talked about was our vertical stretch, right? What did we say happens to our slope to make a stretch happen? Right, it needs to get steeper or increase, right? So currently, for my parent function, my slope is just 1. Anything bigger than 1 is going to be a stretch. So maybe we'll use 2x. Y equals 2x for a stretch. So I'm still starting at 0, 0, but I'm going to go up 2 and over 1. All right. All right, the next thing we talked about was reflection. And what did we say makes a reflection happen? Everything's opposite, or it changes the sign of your slope, right? So for my parent function, my slope was positive 1. If that was reflected, it would become negative 1, right? So y equals negative x would show reflection. I'm still going to start at 0, 0, just going down 1 and over 1, or up 1 over 1 in the negative direction. Alright, so it's the exact same as the parent function, just slanted in the other direction. All of the y values that were here have now been changed to negatives. All the negative y values have now been changed to positives. Right? Alright, and then the last thing we talked about was translation. Alright, we said if you add something or take something away from your y-intercept, that's going to move this thing up or down. Right? Okay, currently there is a y-intercept of 0 in the parent function. So maybe I'm going to keep the slope negative so that we don't have so many lines over on that other side. But the translation portion of this would be to maybe do -2 for my y-intercept. This part right here is the translation. Okay. So instead of starting at 0, 0, I'm going to start down here at -2, but I'm still just going to go up 1 and over 1 in the negative direction, or down 1 and over 1. So if you notice, the slope of that line didn't change at all, right? It's the exact same as the one we just graphed. We just picked the whole line up and moved it down 2 spots, right? Okay, so now that we've kind of reviewed all of our transformations, I'm going to go ahead and pass out today's assignment.